Good afternoon, everybody. Today we are going to be talking about hypothesis testing, which is going to get us started um, in regards to actually getting into statistics. So we're going to be focusing today on hypothesis testing, but it's going to build us up into getting into and understanding psychological statistics. This is just what we're going to be doing today. I'm going to go over skewness interpretations in just a couple slides. Then I'm going to walk through assignment number 9, which you will get today, but it honestly should only take you a few minutes to actually do. It's not too complicated. And then we're going to get into hypothesis testing. Just as an FYI, let me look at the syllabus. So there is the next exam number 3 is this coming Monday. This afternoon, I will be getting you a study guide, but we will have more time on Friday to answer any questions, like we always do the day before the exam, or the Friday before the exam, I guess, to answer any questions you may have about any material on the actual exam. So before we get into hypothesis testing, let's just do a really quick review. I'm sharing my screen, okay. Let's just do a really quick review of skew and how to figure it out on SPSS and interpret it. So this should be review. Here I have a graph that represents data that has no skew. So data that is symmetrical. There should be review. We covered skew, or I talked about skew last week, and I showed you graphs and what positive skew and negative skew looks like. This graph I like because it puts numbers to it. So hopefully you can see that it actually is symmetrical. For example, when data there's no skew or data symmetrical, the mean, median, and mode is all the same, right? Directly in the middle. And we can see as we go through each side, there's 21 people just to the left of it. There's 21 people just to the right. As we get further, let's look at the very extremes. There's only 3 people on the very extreme, and there's 3 people over here. So hopefully you can see, this data is symmetrical. There's an equal amount of people to the left of the middle and to the right of the middle, perfectly symmetrical. Now, in the real world, data never is truly symmetrical. You would be very rare to find, this distribution of participants, but this gives you an idea. So this brings up the idea of something called positive skew, or this is where a majority or most of your participants are on the lower end of your scale. And you can see once, just hopefully this is review, but a majority of the participants are on this lower end of whatever the scale is measuring. So if you could imagine if this was a self-esteem scale, some of your groups are using self-esteem scales, and your data was positively skewed, that would mean a majority of your participants fall on the lower end of self-esteem. They have lower self-esteem. And less participants have higher self-esteem. Vice versa for negative skew. There's more people on the higher end of the scale. So once again, if this was a self-esteem measure and your data came out negatively skewed, it would just mean that more people have higher self-esteem in your sample. All right, so I want to talk about, this slide is going to be really informative. Make sure that you know it's here whenever you have to actually interpret skew for your homework assignment and coincidentally for your paper. But whenever you get skew from SPSS or any statistical software package, it just outputs a number. It says, hey, your skewness value is whatever, and it gives you a number. And this is how you interpret that number. And we'll get into how to actually find skew in a little bit. I'm going to walk through assignment number 9 for you, and it has instructions on how to find it. It's just a click of a button. But would say you do the click of a button and you find the skew and it gives you this value. What does this value mean? Well, if the value ranges from negative 0.5 to 0.5, so if it falls anywhere in between that, you can interpret that as, oh, my data is relatively symmetrical and there is no skew. If that value falls between -1 to negative 0.5 or 0.5 to 1, it means it's moderately skewed. And if it falls in this negative range, that means it's a negative skew. And if it falls in this positive range, it means there's a moderate positive skew. So moderate negative skew, moderate positive skew if it falls in between these two values, or these four values, I guess. Then if it's less than -1 or greater than 1 or greater than +1, it means it's highly skewed. And then once again, anything greater than 1 positively is positive skew, anything less than -1, negative skew. So your job, right, or your, I guess, goal, once you see this skewness value, is determine if the variable has no skew, moderate or high skew, and if it's positive or negative. So hopefully this was just a quick review of skew, and now you actually know how to interpret it. Let me give you an example. So assignment number 1 is already pulled up. Actually, let me do it on this one. Or not, excuse me. Assignment number 9 is already up. So check it out at some point, but here it is. Actually, let me just go through assignment number 9 first, and then we can look at the skew specifics part. So this is assignment number 9. Shouldn't take you that long. It is due on Friday at midnight on Friday. But like I said, this honestly should probably take you like 10 minutes, 15 minutes max to do. Yeah, so there's two parts to this. First, you're going to find some descriptive data, and it walks you through it. But step 1 is going to be calculating demographic statistics. So in all of your drafts, your intro, what it would be, your methods drafts, you talk about like, hey, here's what our participants. And I told you to put in like X's or pound signs wherever numbers actually had to be. Step number 1 tells you how do we find those numbers. Well, you go analyze descriptives, frequencies, and then just follow the instructions. I'm not going to walk through it. Just follow these instructions, and it will give you the mean, standard deviations, things you need to know for your specific variables. And so make sure you go back in. I have it highlighted here. Make sure you go back into your methods section and just put in this information. It'll tell you, like how many males and how many females do you have? How many people are freshmen, sophomore, junior, seniors? How many people said, oh, I'm not any of these? So make sure you just go through these and update your paper. But you don't have to like resubmit your methods section, just on your own. Make sure you update these numbers. Then it's going to ask you to create a histogram for the scale you created. So go ahead and do that and then paste it at the bottom. And then it's going to ask you to do descriptive statistics for your variables. So for your independent variable and your dependent variable, follow these instructions. I give you a little extra instructions to make sure that skewness is checked. So it's step-by-step instructions like they've always been. And it's going to give you a skewness value. But it's going to give you some other stuff. And then once again, just follow along with the instructions. This is basically what the entire homework assignment is, or what you have to produce, is just 2 to 3 sentences that talks about, hey, here's the mean and standard deviation of my independent variable. Here's the mean and standard deviation of my dependent variable. And then you check the skewness. If one is skewed, you just report on the skew. Hey, majority of my participants in this sample had high skew, and which means, they had high self-esteem or they had low self-esteem. Anyways, I want to show you what skew looks like on SPSS. So to do it, so this is just a data set of my own. You go to Analyze, Descriptive Statistics, Descriptives, and it's going to pop up this thing. Let me reset it. It's going to pop up this thing, and all your variables are going to be over here. Let me just find the one I want. So let's just look at social media addiction, right? So you bring over your independent variable. Where's depression? That doesn't matter. So you bring over your independent variable, you bring over your dependent variable, you click options. It's going to bring up this box. You make sure mean, standard deviation, minimum, maximum are clicked, and then you just click skewness. Continue, okay, and it's going to give you an output. So just ignore all this. And this is what your output's going to look like on SPSS. And so you could see if I wanted to report the mean, of my independent variable. Here's the mean statistic, so it'd be 2.39. Here's the standard deviation. You guys all know what that means, and you can see how to report it in your paper. But here's the skewness value, this 0.256. So what does this 0.256 mean? All right, let's go back to the PowerPoint. 0.256. Well, 0.256 falls in between negative 0.5 and 0.5, so it means there's no skew. So in my paper, I could just say, oh, hey, this variable, my independent variable, had no skew. The data was symmetrical. Let me show you an example of one where it is skewed. So let's look at this variable right here. So you can do this for multiple variables at once. You don't just have to do one variable. You can do your independent variable and your dependent variable, and it'll just output it in the same table. So I did it for a couple different variables here that I'm interested in. And we can see in the skewness statistic that, oh, it looks like isolation is really skewed. And it's really positively skewed because the number is greater than 1. It's 1.728. So I would report in my first paragraph of my results, following along with homework assignment number 9, oh, hey, my isolation variable, let's just pretend that was my dependent variable. Isolation was highly skewed, and it was positive, meaning that most of my sample reported what is this, isolation? They reported feeling less isolated. And so let's look at this graph. So I plotted out this histogram graph, and we could see this. Look at this data. This is really highly skewed, right? Most of my participants are in the low end of this scale, meaning that most of my participants reported low levels of isolation. This is an example of positive skew. And I can see that it's positively skewed just by looking at this skewness statistic. All right, so I just wanted to show an example. There are step-by-step instructions on assignment number 9. Come back to this slide if need be, if you need to remember to figure out, is it no skew, moderately skewed, or highly skewed? All right, make sure you check out assignment number 9. Well, obviously, make sure you do assignment number 9, but there are step-by-step instructions for how to do everything on that, like there is in all the other assignments. But yeah, so let's do this Friday. All right, now that we got that out of the way, let's go into hypothesis testing. So you all should have seen this PowerPoint slide before. We talked about it last week, but now we can add to it. So we've asked a question, right? The research process so far. So we asked a question. You formed a hypothesis in your group. You think that social media will be related to self-esteem, or you think that exercise will be related to self-esteem, or body image and self-esteem, whatever your hypothesis is. You defined your variables. You figured out how you want to measure them or assess them. You designed your research study. You collected your data. And on assignment number 9, you summarized the data using descriptive statistics. So that's where we're at so far. But what comes next? What comes next? So we've collected data from a sample, right? We collected however many participants we have, 200 something, whatever it is. But we want to make conclusions about the population, right? We collected this sample. We just don't want to talk about our sample. The whole point of psych research is to say, hey, we collected 100 participants, and these 100 participants are representative of a bigger population. So we actually want to make our data relevant to the big population. But the question is, how do we determine whether the stuff that we find, the patterns that we see in our sample, are real? How do we know that they are actually representative of the big population? Well, we can use something called inferential statistics. So we've already done something called descriptive statistics. This is where you just look at one variable and you say, hey, here's what the mean is, here's what the standard deviation is it skewed, right? What's the mode? You just look at the real nitty gritty details of a specific variable in your sample, and you just describe your sample, right? Descriptive statistics, you're just describing your sample. Well, inferential statistics are techniques that allow us to make conclusions about the population from our sample data. there's this big picture question that is going to be the theme of today's lecture, and it's, do we have enough evidence to conclude that the pattern or the results that we found in the sample data exist in the population? So that's the big picture question that we're going to be trying to assess today. And we're going to do that using inferential statistics. So today is really going to be focused on this idea of hypothesis testing. And I'm going to split today's lecture kind of into two. So today's lecture is going to be split into two in a sense of, we're going to talk about the theory or the behind the scenes look into inferential statistics and hypothesis testing. And then I'm going to compare that to, well, here's what we actually do in practice in SPSS. It's important that you have a good foundation of the theory or what's going on behind the scenes and how to actually apply this in SPSS or like any researcher would. So let's get started. So the first thing that we need to differentiate is this idea of null hypothesis and alternative hypothesis. Can I get a thumbs up in chat? Has anyone heard of the null hypothesis? All right, I'm seeing one, seeing two thumbs. Okay, so a couple people are saying yes, good, okay. If we were in person, I'd ask, where have you heard of this? I would like to know like what class. But anyway, so there's this idea of a null and alternative hypothesis. And you all have created an alternative hypothesis. An alternative hypothesis is just a hypothesis that says, hey, we hypothesize that X is related to Y, right? That would be an alternative hypothesis for correlation. We hypothesize that exercise is related to self-esteem. We hypothesize that social media is related to depression or self-esteem as well, or perceived stress. It's just a hypothesis that says two things are related. On the flip of that, the null hypothesis just says, hey, X is not related to Y. Social media is not related to depression. Exercise is not related to self-esteem. One way to kind of think about the null hypothesis is, as a researcher, you're going to stand up, right, and say, hey, I think that social media addiction is related to depression. And the null hypothesis is just some guy in the crowd going, screw you, no, it's not, they're not related. That's what a null hypothesis is. It just says, hey, whatever your prediction is, it's not true. There is no relationship. In parentheses here, this is something that you may see, probably not in this class, but maybe in 204, depending on what professor you have and what they emphasize. But this H1 and this H0 are just symbols to represent alternative hypothesis and null hypothesis, just something to keep in the back of your head. So we have this idea of an alternative, two things are related, and the null, things are not related. So let's dive a little bit deeper into null and alternative. So hopefully you can see conceptually that these two complement each other, right? The null and the alternative complement each other in that only one can be true, right? If your alternative is true and it turns out that social media addiction is related to depression, well, that means the null can't be true, right? If it's true that they are related, it means if you say they're, let me rephrase that. It's weird phrasing it like this. If you say that two things are related, obviously them being not related is not true, right? So it can only be one or the other. It's either they are related or they're not related. It can't be both. So the alternative and the null are opposite of each other. And I don't want to harp on this too much because it seems like I got a bunch of thumbs up in the chat. It seems like most people have been exposed to null and alternative, so I won't harp on that idea too much. But they are opposite of each other, and only one of them can be true. And it just so happens that the alternative hypothesis typically maps onto your research hypothesis. All of you created hypotheses saying, some two variables are related, and that is an alternative hypothesis. Now, in psych statistics, we actually are going to be testing the null hypothesis. And now this is an idea that's going to come up several slides from now. So I just want you to keep it in the back of your head. In psych statistics, we're actually going to be testing the null hypothesis. All right. This idea is going to come up later, but just keep that in the back of your head. But let's move on for right now. All right, this table. All right. So I want to focus on the top half of this table first, and then we can focus on the bottom half. So this idea of non-directional hypotheses. Actually, give me a thumbs up in the chat again. Have you been exposed to the difference between non-directional and directional hypotheses? All right, seeing a shaking head. All right, no, someone said yes, but majority of people, no. Okay, good. So you've done both, actually, and I'm going to show you an example, but you've done both non-directional and directional. But let's focus on non-directional right now. So a non-directional correlation hypothesis just says, hey, I think this is related to that. I think social media addiction is related to depression. It's just simply saying, I think one thing is related to another. Do I have an example? Okay, actually, let me go to this slide first to show the difference, and then we can go back to that other slide. So non-directional is just, we hypothesize that social media addiction is related to depression. I'm not saying how I think it's related, just the fact that it's related. I think it's related. Directional gets it more specific. So specifically, we hypothesize that participants who report more social media addiction will report more depression. So you can see I'm making an actual prediction here, and I'm saying, hey, people who do more of this will report more of that. So all of you have made both non-directional and directional hypotheses for your study, right? You said, hey, we think that exercise is related to self-esteem. And then you go on to be more specific in the sentence right after that, and you give a directional hypothesis. And you say, specifically, we hypothesize that participants who report more exercise will report more self-esteem. Or participants who report more or higher body image will report, what's that group doing? Higher body image will report higher self-esteem. So you can see how a non-directional hypothesis just says, hey, simply, they're going to be related. The directional hypothesis, on the other hand, gets a little bit more specific. All right, so knowing that, let's go back, but still let's focus on this non-directional box, or these top two ones. So there's a bunch of different ways, or there's a bunch of different statistical tests that researchers can use. In your study, you are focusing on a correlation, right? You're just looking at the relationship between one variable and another variable. But actually on Friday, we're going to learn about another one. Or I guess we haven't really learned about correlations yet. That comes next week. But on Friday, we're going to talk about something called a t-test. And a t-test examines group differences. So it looks at one group and it looks at another group on some variable, let's just say social media addiction, and it says, is this group different from this other group? So we could imagine, we could say, do boys and girls differ on their levels of social media addiction? Do boys and girls differ on their levels of depression? So there's multiple different stats questions we could ask, and there's multiple different alternative hypotheses, right? A hypothesis for group differences is going to be worded different than a hypothesis for correlations. So why do I bring that up? So these two boxes show some words or some key phrases for alternative hypotheses and null hypotheses to help you differentiate between the two. So let's focus on this is related to, because that's an example of a correlation. So, we could say, I think social media is related to depression. That would be an example of an alternative hypothesis. And I didn't make a direction, so it's non-directional. I just think the two are related. So social media addiction is related to depression. Well, I can make a null hypothesis from that. Social media addiction is not related to depression. So if I were to give you an alternative hypothesis, or actually just in your own head right now, take 15, 30 seconds, try to come up with a null hypothesis for your group's alternative hypothesis, right? You all came up with an alternative hypothesis. Try in your head, applying this logic. You all came up with one that is worded like this, right? We think X is related to Y. We'll try to come up with the null hypothesis for that. X is not related to Y. I'm just going to give you 10, 15 seconds. It shouldn't be too complicated. All you need to do is really just add one extra word in. Just say not. All right, hopefully you thought about it, right? Shouldn't be too complicated. You just have to say not related to. We think, or the null hypothesis for one of your groups could be exercise is not related to self-esteem. Social media is not related to self-esteem. Body image is not related to self-esteem. A lot of people are doing self-esteem. But yeah, so hopefully you can see how if I gave you an alternative hypothesis, you can form a null hypothesis just by saying, hey, they're not related. A few of these other examples in this box are for different types of psychological tests. So like dissimilar, a difference is t-tests. Remember, t-tests are examining group differences. So if I say, hey, boys and girls differ on their levels of social media addiction. Well, the null hypothesis would just be boys and girls are similar, or there's no difference between boys and girls. Boys and girls don't differ on their levels of social media addiction. All right. Can I get a thumbs up? Does this idea of null and alternative hypothesis complementing each other, right, make sense? I don't want to harp on it too much if people don't understand it, or if people do understand it, excuse me. All right, cool. So you can also apply the same logic to directional hypotheses, right? We think that, and I don't like the examples that we have here, but apply, whatever your hypothesis is. I think that people who report more social media addiction will report more depression. The null to that would be people who report more social media addiction won't report more, more depression, right? You just, whatever the alternative directional hypothesis is, you just say, hey, that is not true, essentially. All right, so let's do some examples, because I think examples are the best way to truly understand the alternative and null. Though it seems like people are giving thumbs up, people have a good idea of it. All right. Age is a significant predictor of income. I give you this hypothesis. Tell me, using direct chat, direct message, is this a null or an alternative hypothesis? All right, only 8 out of 15 people responded, but that's on you. Okay, so I'm seeing a bunch of alternative. Yeah, I'm seeing a bunch of alternative, which is the correct answer, right? We are saying, hey, they are related in some way, right? That's the theme of an alternative hypothesis. You're saying two things are related, or there is some significant thing going on between some variables. Next up, tell me if it's directional or non-directional. Okay, so I'm seeing a split between directional and non-directional, almost like an even split for the people who responded. So let me talk a little bit about why it's non-directional. So it's not directional because I'm not saying people. Let me give you an example of. Let me make it into and into a directional hypothesis. So an example of a directional hypothesis using these two variables would be I think we hypothesize that younger participants make more, right? It's actually saying what we think the direction of the relationship is. And here we're just saying, hey, age is related to income. It's a significant predictor of income. Well, we're not saying do younger people or do older people make more money. That would be directional. So if I were to give you this hypothesis, so for the people who said that that was directional, does that make sense about why it's non-directional? Because I'm not making a prediction. I'm just saying, or I'm not making a specific prediction. I'm just saying, hey, they're related. Okay. So if on a test, if I were to give you this alternative hypothesis, age is a significant predictor of income, can somebody unmute themselves and tell me what would the null hypothesis be?
Age is not a significant predictor of income?
Perfect. Super simple. Age is not a significant predictor of income, right? We have the alternative. They are related. They're not related, or they're not a significant predictor. Whatever language we use in the alternative, you can just say not. Make sure it's grammatically correct. You might have to use some other version of not, but that's what the null is. It's just, they're not related. All right, let's do another one. In the direct chat, tell me if it's directional and if it's directional versus non-directional, and if it's a null versus alternative. Gay males and heterosexual males have similar mental health scores. All right, so I'm seeing a bunch of different answers. So let me walk through why the correct answer is null and non-directional. So it's null. So remember, the whole point of an alternative. Okay, so this is hard to, let me show you the alternative, because I think seeing the alternative is helpful in recognizing why that one is a null. So we can see here that the alternative hypothesis says, hey, these two groups are different. And remember, the null says, hey, no, they're not. They're the same. So let's go back to this. Remember, the alternative hypothesis says, hey, they are different. There is a significant difference between these two groups. The null, on the other hand, says, hey, you're wrong. There is no difference. So if a hypothesis ever says there is a difference, or things are related, or this does predict that, that's always the alternative. If something says there is no effect, if there is no difference between two groups, or if they're not related to, wow, if it says similar, that is, hold on. Yeah, so if they are similar, so that is a null hypothesis. That got confused there for a second. Yeah, so that is why it's a null hypothesis. We're saying they are similar. They are not different. And it's non-directional because we're not saying which one has more, right? Or which one has higher mental health scores. That would be directional. If we said, hey, gay males have higher mental health scores than heterosexual males. So the alternative to that would be gay males and heterosexual males have different mental health scores. So hopefully you can see why this one is the null, because we're saying they are similar. There's no difference. And here's the alternative version of that. All right. And using direct message again, children are more creative than adults. Is it A, directional and null, B, directional alternative, C, or D? All right, from the people who responded, I am seeing a majority of the correct answer, which is B. It is directional because we're saying, hey, children are greater than adults. We're not, and it is alternative because we are saying they are different, right? We're not just saying, hey, children are different than adults in creativity. That would be a non-directional one. What we're actually saying is, hey, children are actually more creative. We're giving a direction. We're saying one is greater than the other, not just that they're different. So it is an alternative, right? A pure non-directional alternative would just be, hey, children and adults differ. It makes it directional because we're saying children are greater than adults. And then the null hypothesis is just that children are not more creative than adults. That would be the null hypothesis to this alternative hypothesis. All right, next one. A, B, C, or D. Psychologists have lower mental health scores than the general population. All right, I'm seeing a majority of the correct answer, and it is B. Once again, right, we're saying there is a difference, right? Psychologists do differ from the general population. And how do they differ? Well, psychologists have lower mental health scores. Therefore, it's directional. So what would the null be then, right? If we're saying that psychologists have lower mental health scores than the general population, well, the null then is psychologists do not have lower mental health scores than the general population. Once again, it's alternative because we are saying they are different, right? We're saying that psychologists differ from the general population. And then we're going on and saying, well, how do they differ? Well, psychologists have lower scores than the general population, which makes it directional. So that is why it's directional and alternative. And then to make the null of that, all you got to do is just say do not have lower mental health scores. All right, I think there's like one or two more. Boys and girls have a different number of imaginary friends, A, B, C, or D. Think about it. Are we saying they are different or the same? And are we making a prediction of who is greater? All right, let me think about this. Boys and girls. Okay, so I'm seeing a split between B and D. So it's good that people recognize that it is an alternative hypothesis. We are saying they are different, right? The actual word different is in there. But it's non-directional because we're not saying who is greater, right? We're not saying if boys and girls, if boys, what are we looking at? Imaginary friends. We're not saying, do boys have greater number than girls? So it is alternative. It seems like everyone got that, but it is non-directional. So what would the null be? We say that boys and girls differ. The null is no, they aren't, no, they don't differ. So boys and girls have similar number of imaginary friends. All right, I think this is the last one. Females do not earn lower salaries than males. A, B, C, or D? Good. I'm seeing a lot of A's in there. And the answer is A. It is a null because we're saying they don't, you have that, they aren't different, right? One does not earn lower than the other, so it's null. And it's directional because we're actually applying that, well, who's greater and who's not, or who's greater and who's smaller. Females do not earn lower salaries than males. They aren't different and they aren't lower, so therefore it's null and directional. And then the alternative, so we could flip it, the alternative would be females earn lower salaries than males, right? So you can work, if I give you the alternative, you can work backwards and get the null. If I give you a null, you can work backwards and give me the alternative. So you can work back and forth between each one if I were to give you one or the other. So if you found that you've been struggling with this, I'd highly suggest to come back to this lecture and practice these couple, and to really figure out or to try to understand what makes a null hypothesis a null hypothesis. We're saying they aren't related or there is no difference. And then what makes it a directional versus non-directional? Are we actually making a prediction? All right, any quick questions so far about null and alternative hypotheses and directional versus non-directional? Somebody says directional means different. No. Alternative means, so directional means you are making a prediction about who is greater or not. So I guess in a sense, there is a difference, but directional says, hey, we think one is greater than the other, or we think that people who report more of this will report less of that. Non-directional is just simply, we think these two things are related. So if it goes past, we think these two things are related, and it tells you, here's how we think that they are related, that's directional. Go back to, if you're reviewing, where is it? If you need to review directional versus non-directional, go back to this slide where, and apply it to your own hypothesis. Non-directional, you just simply state, we think that social media addiction is related to depression. Directional, you then follow up with that and get more specific and say how specifically those two variables are related. All right, let's move on to see what's up next. All right, so you're a researcher. You came up with a hypothesis. And for you guys, they were alternative hypotheses, right? There is a significant relationship between social media addiction and depression. Throw your own variables in there if you want, if you need that to conceptualize. And then, so that was our non-directional alternative. And then specifically, participants who report greater levels of social media addiction will report greater depression. So we have our directional and non-directional alternative hypothesis. Then we can come up with a null hypothesis. There is no relationship between social media addiction and depression. Participants who report greater levels of social media addiction will not report greater depression. Okay, so we have our null hypothesis. Step number 2, you gathered your data. Let's just pretend we ran your analyses. I'm going to be showing you how to run correlations next week, but let's just pretend you ran your analyses and we have your output. So the next logical question is, well, is your alternative hypothesis correct, or is the null hypothesis correct, right? Is there a relationship, or is there not a relationship? That's what we want to answer as psych researchers, right? Is your hypothesis true or is it not true? And if it's not true, that means by default, the null hypothesis has to be true, right? That's going back to that idea of the null and the alternative complement each other. So I'm going to throw you some statistical language out there, but it's the idea of, can we reject the null, right? Can we look at the null and say, hey, that is not true? And what's the null? The null is saying there is no relationship. Can we look at that statement, there is no relationship, and say that is wrong? We reject that idea. That's actually what psych stats are doing. Remember, going back to that slide where I said we're actually testing the null hypothesis? This is that idea. And so that idea is starting to come back, and you're really gonna see it in the next couple of slides. Can we reject the null? And what's the null? There is no relationship. All right. So this is where we're gonna split in between. We're gonna talk about what this means in theory or behind the scenes, and what this means in practice. So I have two statements here, and they're gonna come up in the next couple of slides. But in theory, how to answer, is your alternative hypothesis correct? We're actually answering, how confident are we that the null is not true? So that is, in theory, what statistical significance, something we're going to talk about in the next slide, is really doing. How confident are we that the null is not true? In practice, though, as psych researchers, whenever I run my data, I don't think about that. I don't think about the null at all. In practice, it's just, is our alternative hypothesis correct? All right, that's probably confusing, I understand, but the next couple of slides are going to tease this apart. So when do we accept and when do we reject the null? That should be the next question, right? If we're testing the null, well, when do we accept it and when do we reject it? And this is the idea of something called significance level. So is our data significant? As you've been reading your research articles, right, for your papers, you probably have seen words like, our results were statistically significant. Thumbs up in the chat. Have you seen that? This phrase or some version of it, we found statistically significant results. Yeah, if you've been reading psych research, you should have seen that phrase somewhere in the results, somewhere in the paper. Well, and if we were in person, I'd say, let's talk about it. But what does this actually mean? Well, if you're reading the paper and you see the words, hey, our results are statistically significant, it typically means their hypotheses were correct, right? You see the words statistically significant, the thing that they are testing and their hypotheses are correct. And that's the in practice side of stats, but we'll get to that. But I want to focus on the theory part of it, the behind the scenes part first. So in order to determine significance level, it's this thing called alpha, or you might have heard something called the p-value. Has anyone, thumbs up in chat again, this is the only way I can do this over Zoom. Has anyone heard of the p-value? Oh, awesome. Okay, cool. This is great. So the p-value is this is the true definition of it, right? The behind the scenes definition, the probability of getting the results we got if the null hypothesis is true. I'm going to repeat it again, and you may still be confused, but I'm going to tease it apart mathematically in the next few slides. The probability of getting the results we got if the null is true. All right, just keep that in the back of your head. So the p-value ranges from 0 to 1. And typically in psych research, we choose 0.05 as an arbitrary cutoff point, and I'll explain what that means later. Sometimes we choose 0.01. But typically in psych research, we choose 0.05, and that's what we're going to be choosing for Psych 203 and Psych 204. 0.05 is our cutoff point. So if you run your analyses, right, and you're in SPSS, and you see a p-value that is 0.05 or less, that means your results are significant. And once again, we'll talk about what that means in a little bit. If you have a p-value that's larger than 0.05, it means your results are not significant. All right. Let's move into let's actually apply this now and let's look at this. And I think this will make a lot more sense. So up in the top right corner, I have just the p-value definition again. Probability of getting the results we got if the null is true. Now let's work through that. So this is an actual a correlation output from SPSS. We're going to talk more about this next week, so I'm not going to focus on all this. Just know that I ran a correlation, this is my own data, between social media addiction and adolescent depression. And because this number is positive, and we'll get more into what this number means next week, but just for the sake of today, because this number is positive, this 0.241, it means we have a positive correlation. People who report more social media addiction report more depression. Okay. The second row right here, and what I have circled in orange, is the p-value. So we have a significance level, or a p-value, of 0.03. Okay, so let's come down here. I worked through this. So a significance level, the p-value of 0.03. Let's convert that to percentage, because it's just a decimal. Let's convert it to percentage. 3%. Everybody with me so far? Just basic math right here. I just converted it to 3%. So what does this 3% represent? Well, let's go up to the p-value definition. There is a 3% probability of getting the results we got if the null is true. All right, still doesn't help you that much, I'm assuming. I'm assuming you're still confused. Okay, let's work through it a little bit more. So let's pretend that we are a God, right? And we are all knowing. And we know for a fact that social media addiction is not related to depression. Right? We're God, we know everything, and we know that the null is absolutely true. We know that social media addiction is not related to depression. If we did this study 100 times, what this p-value is telling us is that SPSS would tell us there is a relationship 3 times, right? 3% of 100 is just 3. So we as a God know that these two variables are not related. SPSS will tell us they are related 3% of the time. Well, so let's work through that a little bit more. 3% probability that the null is actually true and we have a false positive, right? If we as gods know that the null is definitely true, there is no relationship, but SPSS tells us there is. And it's going to tell us that 3 out of 100 times. It's going to tell us the wrong answer 3 out of 100 times. So we can also rephrase that. I'm phrasing these multiple different ways. They all mean the same thing, but I'm phrasing it multiple different ways because it may help it click for some people. But we can also be 97% sure that our results are not due to chance or some error. So let's go back to this p-value definition. Probability of getting the results we got if the null is true. So if we're a God and we know that the null is definitely true, there is no relationship, a p-value of 0.03 tells us we are going to get this significant finding only 3% of the time. And going back to this slide, we have this arbitrary cutoff of 0.05 or 5%. So we know that, or this cutoff tells us, hey, we're actually confident that these results are actually true. We're confident that the null is not true because we're only wrong 3% of the time. That's kind of what this p-value is telling us. It's the probability of getting these results if the null is actually true. These results are telling us, hey, there is a relationship. And in the real world, if the null is actually true, we will only get this result 3% of the time. And we're okay with that as psych researchers. If it was greater than 5% of the time, and I'll show you an example when it's not significant, but if it was greater than 5% of the time, or a p-value of greater than 0.05, we're going to be like, wait a second, there's something fishy going on here. We may actually be wrong, or this data may actually be wrong. All right, once again, I'm going to repeat it. There's a 3% probability of getting these results if the null is actually true. And this is saying the null is not true, right? It's saying, hey, there is a positive correlation between these two variables. And 3% of the time, we're going to be wrong, or this is going to be wrong, and the null is actually true. And as psych researchers, because we made that arbitrary cutoff of 0.05, we're okay with being wrong 3% of the time. All right. Thumbs up, direct message. How many people are still confused? It's a confusing thing. The behind the scenes of the p-value is really confusing, in my opinion. There's a 3% probability that the null is actually true, and we have a false positive, right? This false positive idea, the test is saying, hey, here, it's significant. There is a positive relationship. 3% of the time, that test is wrong in this specific scenario. Now, I could go behind the scenes and tell you mathematically why that's true, but that's just going to confuse all of us. Even I am confused a little bit by it. I'd have to work through it myself. It's saying 3% of the time, the null is actually true, and this is a false positive result. These results are actually wrong, and the null is true, but only 3% of the time. And because we have that cutoff of 5% or 0.05, we say, hey, we're okay with being wrong 3% of the time here. All right, so let me show you what this means in practice. And it's a whole lot easier when you, as a researcher, like, don't get thrown off by like statistics and psych stats because that was confusing. In reality, I look at this number, right? I'm going to do it really fast and then we can work through this. But because I've done this so many times, I see, okay, this value is less than 0.05, right? 0.03 is less than 0.05. I know that means it's significant. And now I can interpret this correlation and be confident that this number is correct. Or it's telling us, hey, there is a significant correlation. And because this number is less than 0.05, I have faith that that is correct. So I can interpret. I know that, because this is positive, people who report more social media addiction report more depression. And I can be confident in saying that because this number is less than 0.05. So that's in practice, that's the purpose of a p-value. So because the p-value is less than 0.05, we can say that the null is not true. Therefore, the opposite must be true. Remember that idea of the null and the alternative are complementary of each other. So the null is not true. Therefore, my alternative hypothesis must be true. We can now interpret these results, this 0.241 correlation, and be confident that they are true. And here's just the interpretation of it. People who report higher levels of addiction report higher levels of depression. And I explain why right here, but don't worry about it. Don't worry about interpreting things. That will come later for next week. Just know p less than 0.05, it means it's significant. Let me show you an example of when it's not significant. So we can see once again, I try to do a correlation between social media addiction and teen height. My alternative hypothesis probably would be, I don't know, it's a dumb hypothesis, but people who report more addiction are going to be taller. Sure, right? It's a weird hypothesis, but whatever. So we can see I run that. SPSS will always give us a number. It will always say, hey, here's the correlation between social media addiction and teen height. Let's say I would ignore, I just held my hand up like you can see that, but let's say I just crossed out this significance level and I as a researcher just ignored the significance. I would say social media addiction, since this is positive, is 0.026, people who report more addiction are taller, right? That's what a positive correlation is. If I would just ignore the significance. But because it's not significant, I know that there is no correlation between teen height and social media addiction. It is not significant. Therefore, the null hypothesis is correct. There is no relationship between these two variables. So let's look at it mathematically in theory, if you want to call it. There is a 66.3% probability that the null is actually true, and the results we have are a false positive. So there's a 66.3% chance that these results are wrong, right? Going back to here, there's a 3% chance that these results are wrong. And we're okay with that, right? 3% is less than that 0.05, that 5%. We're pretty confident that these results are right. Go back here, now we're 66% sure that they're not correct. And if I, to do some math, what is that, like 34? We're 34% chance, we're 34% sure that these results are correct. That's not good enough in research. We need to be not like 95% sure or more. So there's a 66.3% probability that the null is actually true and we have a false positive. That's way too much for us as psych researchers. So that's the theory behind it, or applying that p-value to that, or applying this to the p-value definition. But in practice, as a researcher, I would just look at this and say, oh, okay, because this is greater than 0.05, we can conclude that the null hypothesis is true, or we can conclude that there is no relationship between social media addiction and teen height. So because this is less or greater than 0.05, the null is true. If it's less than 0.05, the null is not true. But when you're interpreting, let's pretend this was your own results, right? Let's go back to something that's significant. Let's pretend this was your own results. I don't want you to sit there and like think through these percentages and be like, okay, it's converted to 3%. What does that actually mean? In practice, all you need to do is look at this number and say, okay, is it less than or greater than 0.05? If it's less than 0.05, I can go ahead and interpret this correlation and be confident it's correct. If it's greater than 0.05, the null is true. There is no relationship between these two variables. All right, that's all I have for today. If anyone wants to stick around and I can ask me any questions you want, I can explain, I can explain any of this in more detail or come up with more examples. I can just run analyses and we can walk through it together. So feel free to stay on after and ask me any questions you have. Just remember that assignment number 9 is going to be due by the end of Friday. On Friday, we are going to work through t-tests. So I'm going to show you different types of t-tests, what they are, what their definitions, how to do them on SPSS. I called an audible in class. Technically, I was supposed to show you how to do some of this stuff by hand. I don't think that's incredibly useful.